And we're on Curiosity Engine number 10. Dice, a 1 and a 0, completed the
Deca.
Deca, completed the 10-finger cycle. It's all down here from hill. All downhill from here.
Exactly. It's all uphill from up there.
From a numerical perspective, it doesn't, I mean, it's bottom 10 are really interesting.
Yeah, but we've established the base, whether we like it or not.
Yeah, maybe you could get like some good value up to 12 because you're still in like the realm of disciples, but then you hit 13, you got to deal with people's prejudices on that stuff.
Let's not script this.
Let's not script And then I guess you could always, I guess really, as long as you're under your age, you always have a reference because you could be like, well, at 23,
Yeah,
you can always,
right,
you can always personalize it at a certain point.
We got a ways to go then.
We should abandon the number system altogether. We should just like go through colors at some point. Like it's like 15, blue, orange.
Yeah,
gray.
abandon numerical frameworks and just start using other models to
add extra dimensions. Add extra dimensions just at random.
Exactly.
You could do it on coordinates. You could have just like GPS coordinates. Like,
yeah, we could do like the 7 wonders of the world or something like that, and
totally
coordinates or whatever.
Absolutely.
See, this is the Curiosity Engine, folks, where it fucking happens.
Dude, I learned this crazy thing about the universe, and it kind of hasn't all the way set into my head, and I learned this years ago, and by years I mean like decades. So check this shit out.
Decades.
Okay, so the age of the universe is like 13.8 billion years old.
Okay.
And
said who?
Exactly. Said who? It's based on some math that was this thing called the cosmic background radiation. So it's a funny story, but I think it was 2 English guys, and they were making a dish to like listen to space. And they like pointed it upside, and they had this hum, this buzz in their signal. And at first they thought it was the fucking pigeons or the pigeon shit. And so they chased off all the pigeons off the dish. It wasn't the pigeons. They were, I'm butchering this story, but they were like pointing their dish at the, and there was just this noise that was coming from everywhere. And they have since used very sophisticated satellites that take these very open aperture, very long term pictures of the sky, and what they found is that there is a little bit of energy from the beginning of the universe everywhere, and it is like you're in the middle of a soap bubble and it went bloop, and it's like you're seeing it, everything sees it all the way around. So what they can do is they take some of that, and then they also take this thing called redshift. So there are these things called
How
quasars.
do they take some of that?
Okay, so there's this thing called a pulsar.
They have like special bottles.
Yeah, exactly. They have a special bottle, and they get their special bottle, and they're just like, they fill it up with quasar juice. They take it, and then they top it off, and then they put a couple of cherries in. They shake it, and then they. You must shake it.
Redshift. What do you do with the redshift to the quasar?
Okay, so check this shit out. So like, it's the Doppler effect with light. So light's the fastest shit in the universe, right? It's a wave, but it has a speed limit. It's not infinitely fast. You can't go, we assume you can't go faster than the speed of light. We have never seen anything that does this.
Anything that goes faster.
We have seen influences travel faster than the speed of light. For example, if you take 2 particles and they hang out with each other, like they get cozy, they'll have the same spin. Then you separate them for as much distance as you want. Like put one on this side of the universe, then go to this side of the universe and take a step back, so it's just inside. And when one turns, the other one turns. There's this thing, Einstein called it spooky action at a distance. And it was like these, once 2 particles entangle, meaning they're part of something together, they will always have an influence on each other no matter where they are. And this is at the like pre-atomic level, like the smallest things that we can find. Yeah. Okay, so there's that. But then the Doppler effect. Okay, so imagine you're standing on a street corner and an ambulance comes by, right? It's coming at you, and then it goes away. It kind of the pitch goes down. It goes as it's going away. And why is this? Because the speed of a sound wave is set, then you add the speed of the car, and then when it's going away from you, you subtract the speed of the car. The sound waves are still going the same speed, but now instead of they're going slightly lower. And a slower sound wave, so it elongates, the wave gets longer, is lower in pitch. So we hear that as a lower pitch. It's the same thing with light on the spectrum. If you think of red all the way to purple, there's so you've got
Yeah.
like red at one side and blue at the other. You can, if you know what the light is supposed to be, you can then subtract out the speed. If a star is coming towards you, its wavelength of light will get faster because it's the speed of the star
Right.
coming towards you plus the light. And if it's
Plus.
going away, it's you subtract the light.
Right.
Yeah. So it's a
Okay.
way that you can back into how fast something's moving towards you or away from you. And
Yeah.
except you need a standard candle, which is what these physicists call this shit. A standard candle, but you don't know how fast. So what they can do, they don't know how bright a star is supposed to be. So, but there are these things called pulsars, or I think it's a quasar. And a quasar is a star that emits a regular beat. It's like, how do they get made? I think it's like collapsed star cores, or there might be fucking black holes involved, but it's a real,
What?
okay, so a quasar is the brightest thing that we can find in the universe. It is so bright that when a quasar happens, it will happen for only like 2 weeks. But during that 2-week period, it will shine more brightly than all the stars in the Milky Way. So they happen about once a day. When you look at the sky, you're just looking for these like fireworks, these super nuclear star explosions. They happen like very what's the word? They happen briefly. They don't last for very long. And when they do, they're super bright. In fact, there's like wood cuttings from like the 1300s and stuff that show when a star would appear in the sky. And then scientists have gone back and found that it was a quasar that kind of blew up. I hope I'm using the right term.
Nice. Yeah,
Quasar,
no,
pulsar.
quasar is an extremely luminous
Yeah.
active galactic nucleus
Yeah.
powered by a supermassive black hole.
Supermassive black hole. Yeah.
Mhm.
It does some
Mass
kind of,
ranging from millions to tens of billions of times the mass of the sun, surrounded by
yeah.
a gaseous accretion disk.
Yeah.
Boom. It doesn't say anything about frequency.
Pulsar. Okay, so maybe it's a
But yeah.
pulsar. Well, one of those two, quasar or pulsar, one of those two. What it does is it emits energy at a very steady pace. Boom, 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 and it never changes. And I'm thinking it's quasars. All quasars do this the same. They all have the same pulse rate. So what that means is when you find one of these guys out there in the world somewhere, you can look at the light that it's going to pulse back to you while it's doing it. And you know exactly what the physics says it had to have been on its side. So then you can subtract or add the speed back in between you and it to see if it's going away from you or see if it's coming towards you.
So you have to have something.
They call it a standard candle. You know what? I'm just going to do it. Standard candle physics. What is this thing? Standard candles in astronomy. Oh, supernova. A standard candle is a class of astrophysical objects, such as a supernova or variable stars that are known for their luminosity. But yeah, I was hoping they were going to give me another name for it, but so you see one of these things out in the universe somewhere, and now you know the spectrum of light it's supposed to send you. And you can see if it's shifted red, which means that it's slowed down, which means it's going away from you, or if it's shifted blue, which means it's speeding up and it's coming towards you.
Yeah.
Turns out everything is headed away from us. And literally every single other thing is spreading out. And it's not just spreading out kinda, it's spreading out like a motherfucker. It's like the speed of light is a certain speed. And that's the fastest thing in the universe. But it turns out the true fastest thing is the expansion of the universe itself. Because there's only been 13.8 billion years of time in the universe, but the universe is like 93 billion, or the light cone around us is like 93 billion miles wide. It's like, how can you have 93 billion light years of space if the speed of light should only give you 13.8 billion years of space? And the answer is that space itself is going it's like every point in space is inhaling and like spreading out. And so anyway, there's not even an edge to this thing. The
It's not
very
even an edge that we can see.
we can only see our light. We can only see the light within our light cone, and we can make inferences about stuff outside of it, but we can't perceive it. It doesn't. Those signals don't come to us. And it's really fucking big. And to think that there's more out there. Yeah, there's just an edge, and the edge is literally 360, 24/7, rushing away from us at faster than the speed of light.
The
Which
wall is forever expanding.
And it's expanding so fast we can't even see the wall. We're not even looking at the wall. We're looking at our own light fading out to black.
Yeah.
And like they're it's just not. It's just unclear what's going on out there. And
Unclear. Yeah.
unclear.
We have to start exploring. We have to figure out how to go faster, boy.
You know what this means, my friend? This means that literally any point, like the head of this pin, is literally the center of the universe mathematically. You can't to be the center of something, you have to find an edge, and then that's your center. But when the edge itself is literally racing away from you at a multiple of the speed of light, and we don't even know if it's fixed, it might be speeding up, and yeah, there's actually no edge. So anyway, it's all edge. No matter where you go, you're at the center of this thing. Isn't that crazy?
Yes.
The geometric center of it all.
Well, is it us that's the center, or is just the whole mass moving away? Is it moving at different rates in different directions, or is it moving at a constant rate in all directions?
That cosmic background radiation has like hot spots and cold spots, so we can tell some differences.
So there may be like there's some toroidal fields in this, like
there's gotta be. There's just gotta be
some dimension. I mean, if all these are like wormholes and stuff, there has to be like.
We don't know if there's really wormholes. It's a theory.
Or not black holes. What's
black holes? Black holes.
Hole?
We don't know that. That's the mystery in Interstellar. That's why we got to deep dive into Interstellar. I put a deep dive placeholder in our psychedelic dojo of love. I put a little tick on there.
Blocker.
I bet you saw that announcement. Dude, so the center, I mean, okay, so like when you look at that cosmic background radiation, what they do is they rewind that and imagine that all goes down to a super tiny point,
and then gives you that number of years ago.
The statistical sort of distribution of that heat might tell you something about that super, super, super subatomic thing that happened that they say inflated and made the whole thing. Except light doesn't happen until much later in the process. It's like 300,000 years or something like that. Like the let there be light took a beat. Yeah. But
how's that? All right.
well, it's just about what you can measure, right? So they're trying to, these scientists are trying to back into what can you take from the evidence that we can see from the beginning event, and what can you infer backwards about it, right? So that's how this theory all comes about. I think it's insanely cool. It's the ultimate honor of the physical world, right? You're like we're gonna watch your birth. It's like somebody
trying to know, man.
Your first shout, you're born, you're like ah or whatever.
Yeah.
And it's like that's the first shout out there. What does that say about lung capacity of the infant universe? Kind of stuff like that.
Lung capacity of the infant universe.
Totally.
Wonder and how old it is, maybe, or how old it will be. Where it's going.
Where it's going. Yeah.
Where's it going?